Hey, what's up guys? This is 3D Bonfire back with an amazing tutorial. And you know what? I was always interested in this X-Particles advection technique and granular simulations and stuff, and I thought I just want to give you an update today on this technique, alright? There is already a tutorial out there from Ethereum where they make this beautiful sand advection here, okay? But I thought it's already 2 years old, and I guess the tools in X-Particles got a little bit faster, so I just wanted to test this. And I think I don't want to do it with the Ethereum logo, but with an Ethereum coin, okay? So NFT is just trending right now, and everybody is trying to do something with the Ethereum coin. I guess I also did it by myself, so I implemented this in a couple of my latest works. It's a trend, you don't have to follow it, but I think it could be a nice idea to build this coin, or right, this logo, and then we want to do some advection with it. Of course, we want to change the setup so we don't just redo what Ethereum is doing here, but we want to give it an update and want to make it maybe even more exciting. So I hope we can do something cool with this one. Also, I was checking all the tutorials on advection. So particle advection, surface advection, sand advection, speed advection, spline advection, and I did all the research for you, so I also want to give you like one comprehensive lesson where you learn everything about advection, okay? So you don't have to go through YouTube and search all this different training and spend like 3 hours to learn it, but you can just watch my course and you know basically everything about it. So no matter if you want to advect splines, you want to advect sand, surfaces or particles, this will be the right lesson for you, okay? So yeah, I guess this will be exciting today. So let's just see how far we can go with this Ethereum coin made of sand today and advect it into sand. Then afterwards, I guess in a comprehensive lesson, I want to tell you everything about advection. But today we just want to go directly into one project, okay? And later, since I'm a paying member of Ethereum X-Particles, I will go into one of their repository files, it's called Spline Advection, just to go even further into the topic so you can see if you're not paying, this is locked, but I'm a member, so I will download this one and I will also show you more techniques about advection, alright? So let's start today with this Ethereum coin, let's build it and then advect it, okay? I'm excited, let's get started. Alright, welcome to Cinema 4D, and you can see I already downloaded 2 images as reference. So let's just select a plane here, put one of these ones on it. I guess in your case, the viewport resolution will be set to default, so it looks quite muddy, but just pump it up a little bit and then you have something like that. Just check the resolution here. So this is 4500 by 3000. So click on your plane, put this one, for example, to just a tenth of it. And now this is like the correct aspect ratio. Just duplicate the plane, okay, go to your materials, throw the other image on it, okay. That seems to be a little bit stretched, so just check the resolution here. It's 480 times 560. So go into your attributes, just type in the numbers, and there you go. All right, so I will just rescale this one. That's nice. And maybe I would just add a second viewport. Oh, it opened over here on my second monitor. I just lock it. Where do I want to lock it? Maybe down here. Okay, so it's a little bit tiny, but now I can go here. Okay, zoom in. And I think maybe we want to build this logo once like a thickened outline like that. And the second one, which is 3D extruded. Okay, something like this one. Okay, cool. So let's go back to this viewport. Put these ones over here. That was stupid, so let's just reframe it. Just follow the blue arrow here. Let's go there and just zoom in on it again. Okay, nice. So I want to build this Ethereum coin, or let's better say the logo in the middle. And then we want to fill this one with particles. And then we want to advect it, that it falls apart like sand. Okay, cool. So I guess we just want to start with a polygon here. Okay, that looks good. I want to rotate it 90 and I want to rotate it 45. Okay, almost there, almost there. So I make this one editable. I will select the points and stretch this one a little bit. Something like that. Okay, that's a good start. KK to get the knife tool. Cut from here to there, spacebar. Cut from here to there, spacebar. All right, nice. So now I just go to point, select this one, and it seems like this one is out. So I just move it out. We have some crazy shading here, so that looks like it's round, but that's not really the case. So let's go into the object and put this one, for example, to 10. Now we reduce the Phong breaking and we can see the angle. Okay, so that seems to be okay, but it looks like the angle is going up here. So we need to put this one up. And it feels like the distance is even from top to bottom. So I just need to put this one up to make this the center line of this parallel object here. So maybe something like that. Okay, looks good. This one, I will move it up a little bit. Maybe that's too much. Somewhere here. Okay, so that looks okay, not bad. So how about the symmetry object? Put the polygon into the symmetry. And I think our mirror axis should be XY. So just go there. Looks like nothing happened, but there it is, okay? So we have one crystal diamond shape here, okay? So that looks nice. I think we can just make it editable, put it out of the null, and we have this object here. I will just stretch it a little bit so it's not so tiny and thin. That looks better. And since I want to have some edges here and there, and we only use it as a volume to put particles inside of it, so it won't be visible, we can also put this one into a builder and a mesher. Put the builder in the mesher, put the poly in the builder. We get something like that, okay. Just put this one to 1, for example, so we have some edges here and there. I guess I want to introduce some smoothing, put a smooth in it. Wow, so this is way too round, so let's put this one to 30. I'll put it to 50. Put voxel size to 0.5. That looks better. Okay, so I think this is good enough. Okay, so from a distance, that looks really beautiful. Nice. I think I want to duplicate the polygon, make this one temporarily invisible, select this one, go to these edges here, select them, right click and go to add to spline, okay? Now we select this spline, kill this one, and I want to move this one down a little bit, and now we will create this element, all right? So I would say press F4 to go to the front view, go to your spline pen, all right, to the points mode, select this point, go to the middle line somewhere around here and connect it with the other point. Nice. Now I select this point, go to my coordinates and just check if this is in the middle. I guess this one needs to be 0. So now it is really symmetrical. F1 to go back to your perspective view. Now I would say you just put this one into an extrude. All right, that looks nice. Just put this one to maybe 0. All right. Make it editable. All right. Get rid of all of this one. And now we have just one polygon here. We need to have this center line. So KK to connect from here to there. Spacebar to get out of the tool. Now I want to extrude this one. Select D. Push it to maybe 10. All right. Select the back polys. D. And you could say, for example, apply. Then you just repeat the last extrusion, spacebar to get out of the tool. And now you will have something like that. Okay, so the shape confuses me a little bit. I don't know why. It's not so complex, but I think we need to have the center a little bit more out than here. Okay, so let's just go to the edge mode, select these ones and select these ones, for example. And I think we need to just scale them down a little bit, maybe something like that. Also, the Phong is too much, so put this one to 10. Now we will have something like that, okay? And I think this is almost working for me, okay? Maybe we can even put this one more together, so something like that. So that seems to be working for me. I just feel like the whole element needs to be a little bit wider, so it's not too tiny in comparison to the mother element, all right? Something like that. Okay, so this is working. I just want to put it down a little bit more to have more of a border between it. And I will also put it into the mesher, put the builder in the mesher, the extrude in the builder. Now we have this ugly mess here, so put this one also to 0.5, for example. And you can also put a smooth in it and put the smooth to 50. And I guess This is nice. So I just press C with both elements. Now we have a top object and a bottom object. And now we want to fill this one with particles. Alright, so I just press C to make these ones editable. And I think it's a good idea to call this one top and call this one, you guessed it, bottom. Alright. And I'm just thinking about if I keep my system separate for the top and the bottom to have two emitters for it. But I guess it makes sense to just duplicate them, right click and say connect and delete. And then we just select these two, Alt G, put them in a backup, null, okay. Hold down Alt, click twice to make this one invisible. And I think we can also get rid of our planes here with the reference on top of it. And now, yes, it is time for an X-particle setup, alright? So how about an emitter? And I already called this one Granular, or you can also call it Sand Advection, something descriptive that makes sense, okay? So this will be our sand particles. I already make this one invisible because now we clone particles into the volume. So let's just make it invisible, go to Object, set this one also to Object and drag the Ethereum inside of it. Now we emit particles from our Ethereum, right? That doesn't make sense because we want to have them static. So we can glue them together like grain and then it will fall apart. So let's just click on emission. First we get rid of the speed. So let's see. All right, that also doesn't make any sense to continuously emit them. So let's just emit for 1 frame, for example. All right, and then we set the emission to hexagonal. All right, hexagonal is just a stacking pattern inside of a volume. All right, so you just get this honeycomb pattern here. And with the particle radius, you can decide how many particles you want here. Okay, so if I put this one to 2, you can see this will get denser. If I put it to 1, it will get even more dense. All right, so I guess when we want to make a final render, we just decrease this number. But for now, let's stick to something like 2, for example. And I really don't like the display mode here. So let's go to display and turn this one, for example, into spheres. All right, let's check it. Okay, now you can really see the stacking of the spheres together. And we want to destroy this one with an explosion. And then these ones will fall apart and will be dragged away. Okay, cool. Alright, and as I said, later when we do the final rendering, when we want to get more detail into the simulation, then we just decrease the radius and the stacking of these particles will get denser and denser. Alright, so that's nice. But for now, let's say we stick to 1.5, for example. Alright, and next I think we want to create some fire here, some smoke that will rise up. And whenever the smoke is touching these particles, the velocity of the smoke will be transferred onto our particles and the particles will move with the smoke and go up and will behave in a physical manner and this logo will get destroyed. Okay, so I guess we just create a little fire here. So give me an explosion effects container and just make it a bit bigger in the height. We don't need to have it so wide and we can make it a little bit more narrow here. Okay, now we just go to it and the voxel size, this will be the resolution of our fire. I think we don't need to have this so detailed because we just use it to transfer the velocity onto our particles. So I guess you can go up to 5 or 6 or even 7. For now I will stay to 5 and we just see how it goes. So let's just add a second emitter and call this one smoke rising, for example. Okay, so very descriptive. Let's put it down here and I just want to turn this one into a box. All right, make it bigger, something like that, for example. I just make it a little bit smaller. All right, so let me for now just switch off the granular for performance sake. So now we can see these particles will be thrown out of this box into all kinds of directions, but that's not what we want. We want to just have particles in the y-axis. Alright, and I think these particles which will create smoke are way too fast. So just go to the speed. Let's put this one to 50 with a variation of 40. And these particles will create our smoke, alright? And to be honest, we don't need to have so many. So put this one to 250, for example. Alright, or put it to 300. Okay, that's looking good. So that could be a little fire here. Of course, right now it doesn't look like a fire, so how about we first go to extended data, give it some physical data and put in some fuel. So all of these particles now have a fuel value of 2, but that's not all what we need. We also need to go right click to the tags and say this will be an exposure source. And hopefully when I sim this, you will see the most ugly fire in the world. All right. I'm a bit confused that the smoke is falling down here. Okay, so okay, that shouldn't happen. Interesting. So first, I guess the radius of these particles is way too small. So just go to your smoke rising emitter, go to the object, go to the emission and increase the radius. Put this one to 10. Alright, and you already can see the radius around these particles is way bigger. I guess it will help when we go to display, go to circle. Alright, and now you can see the radius of these particles, which will create the smoke or the fire. Okay, 10 seems to be a good value here, but I think we're not there. So we need to make this a bit more interesting. So I think first what is going wrong here, that the fire is also going down. And I think that happens because these smoke rising particles shall not be affected by the exposure effects, okay? So we only want to have our granular or sand particles to be affected by that smoke, but to have the smoke rising also affected by exposure effects doesn't make any sense. So just go to modify and exclude this one. And hopefully now this will look better. All right, almost the same. So this one is still going down. And I think this has to do with the gravity set in the exposure effect. So I guess we almost can set this one to 0. Because we don't need to have an additional force up or down, but we already have this motion through the particles, so the smoke rising particles, which will go up and will create the smoke and the fire. So we already have this impulse in the y-axis plus. That's why we don't need to have an additional gravity here. So let's check this once again. And now we have this fire going up. All right. I just increased the timeline just a little bit here. Okay. But overall, I think this is a little bit boring, to be honest. So how about when we go to our emitter and give it some radius variation? So give me a variation of 10. So we should have huge particles, all right? And we should have smaller particles. And maybe this will make it more interesting. And honestly, I think it's just a little bit more interesting. So maybe we can also change the vorticity. So this is like a turbulence in the tiny curls in the smoke. So for now, to just see it better, I make the smoke rising particles invisible to focus only on the fire. All right, I mean, that's reasonably ugly, but we only use it to transfer the velocity data onto our particles. So that doesn't have to look good, but let's see when I rise up the velocity to 30. All right, now you get more of these tiny curls. So that was not an improvement. So I put it back to 5. The turbulence strength, I just want to test this one. Okay, this is also giving me more curls here. That's way too intense. Maybe put it to 10. Increase the turbulence radius. Let's see how this will look. All right, let me put this one to 50. Okay, still way too much. Put it back to 10. So I think we have more curls here. So maybe this will look a bit more interesting. We can also go to the tag here, to the source tag. And for example, increase the effect of the velocity, put this one to 400. Now you can see the velocity is increased and we get this intense curling here. So I think this is really so much more interesting, but I think it's too intense. So check it once again with 100. This is pretty boring. All right, put it to 150 just to get a little bit more of this rolling curves here. And I think that could already work for us. All right, let's just think about the voxel size one last time. So of course, when I decrease this one, we get a slower sim, but we get more details in the curves and the smoke. All right, so you can see this is way more detailed when I put it up to 5. It will sim faster, but you lose detail. So how about 4? Let's check it. And I think that's good enough for now. So we don't really need to have this super detailed. So you don't need to have this as the most amazing fire sim because we don't even see it. Okay, we only use it to transfer data onto our sand particles. So put it back to 4 and we can go to the next step. So let me activate both emitters again. And now you can see I want this fire to advect my particles here. Right now, nothing is happening. the fire has no effect on our particles. So let's just change that fact. Therefore, we just open up our Explosion Effects, go to Advection and activate it. Now let's check this once more. Now you can see our fire has an effect on our particles and they will be dragged upwards. And by the way, now would be the right time to really exclude the explosion effects from the X particles emitter smoke rising, because you don't want to advect these particles also, or your whole system will be just total chaos. Okay, so just be sure to exclude it from smoke rising. Alright, so we are one step closer to our effect we want to achieve, but you can already see these particles, they don't really behave like sand. So just to see it better, let's get rid of the explosion effects in the viewport, also of the smoke rising particles. And as you can see, these particles, they just behave like typical particles. They move with the smoke billows, but this looks nothing at all like sand, and that's what we want to change now, okay? Alright, and therefore we need another dynamic solver, and in that case it is a fluid FX solver, okay? And this one should only have an effect on our granular again, so go to your smoke rising and also exclude this one from the emitter. Okay, perfect. Alright, so to make this behave like sand, we can play with this settings, but we also need to play with our emitter settings. So if you go to extended data, fluid data, you need to change this one to granular, alright? Now you can play with a lot of settings here, but I can already tell you, if you want to make something that has friction like sand, put this one to the maximum value here, okay? The stability factor will tell the particles when to break from one another, okay? So how much velocity or distance, I'm not sure what it really means, this number, but if you increase it, for example to 1000, then these particles will be really hard to separate from one another. And if you go lower with it, you don't need to have so much velocity or pressure to separate them from another and make them break, okay? So I would say for now, just put this one to 12. And let's just test how this is looking. And I think because this is already really slow, I will just put a cache into my scene, alright? And I will just put an output path here. Alright, and I will make an external cache here. If you set this one to internal, it will be saved in your Cinema 4D file, but the risk is that your files get pretty big and then it will take ages to open up a Cinema 4D file. So please set this one to external. And in my case, I will just cache it for you, but you don't have to do all the caching. I will do it for you to just show you the different effects, and then you can just make the final cache when everything is set up, so you don't have to cache all the time, okay? So let me just show you how this will look, okay? So I built the cache. And this is the cache with the settings. So we didn't change anything, but friction, put this one to 100 and the stability is 12. Let's just make the explosion invisible here. Alright, so it already behaves a little bit like sand, but overall this is breaking too early and looks too loose. Okay, so we get some clumps here, that looks nice, but then the effect is really strong. It's not so bad, but we obviously can improve this one. Another thing we should adjust is if we go to our fluid effects and go to the accuracy. Okay, so this one is set to fast, but the higher we go with this pre-made settings, we introduce more substeps, and more substeps means with granular you get a more sticky behavior. Okay, so substeps are just necessary to glue that stuff together. So how about we just switch this one to medium and do another cache and compare them. Okay, so let me just cache it with the medium settings. Alright, the cache is done, and you can see with medium this looks a little bit different. So now there is more stickiness between these particles. The granular overall looks more interesting. What I really like about it is that this first element collides with the top part, then this will be pushed up and stuff is breaking here. Okay, so I really like this one. It's almost like this one is going through it and is destroying it. Alright, really nice. Let's just make a direct comparison between medium and fast. Okay, so this is the medium we just saw right now. Now you can see it's sticky, but overall it also tends to break quite a lot in the end, okay? This one is the fast one. This was breaking way earlier, so we already had a lot of breaking here. In direct comparison, for example, we go to frame, let's say 90. The medium one is still in a good shape here, and when we go to the other one, to 90, you can see a lot more small details there. If we go to, for example, 110, the fast one is almost dissolved here. And in comparison, the medium one is more sticky. Okay, interesting. So how about we check this one with the high settings? So let me just cache this one and then we compare it again. All right, so this is the same sim with the high settings. And this one looks even more cohesive, like it's more like sand, like grain, it sticks together. Just be aware that if you go up with the settings to high accuracy, the sim time, the caching time, of course, will also go up. So in my case, this one took like 1 minute and 7 seconds. And sadly, I didn't compare it with the medium and fast, but of course, I guess fast was like 30 seconds, for example, then 40 seconds, and this one is already 1 minute and 7, okay? And here I made another preview. So this one is the high setting. And once again, you can see this one sticks more together. If we compare a frame like 120, for example, with the medium, let's just go here and put the fast also to 120. So you can see fast one is really destroyed here. That's the medium and this is the high. Okay, so even more stickiness, and I think it gets better and better. Okay, all right, there is one more pre-made mode to go, so set it up to accurate, and now the settings are even higher. Of course, you could also go to custom and do that all by yourself, but to be honest, this is getting quite complicated, and these pre-made modes, they are really helpful to just go step by step up with your quality. All right, so now I'm curious how fast the accurate cache will be and how good it will look. So let me once again cache it. All right, so this is the accurate cache and it already took 1 minute and 28 seconds. All right, so now this is really sticky and it's hard to break this one. So it will hold its shape longer before it will get destroyed. All right, so let's compare it again, make a preview. Once again, I go up to 120. You can see this one was the high settings, this one was the medium, and this was the fast. Interesting. Okay, so the accurate pre-made mode here is really cohesive. And I guess in the final settings, I will go with something between this one and this one. Maybe high is already enough. Okay, cool. All right, so by now you have a good feeling for these 4 different pre-made modes, which will influence our granular, but also these settings will have an effect on how this sand is behaving, okay? So I guess I want to do a couple more caches. As I already said, you don't have to do it. You can just lean back and enjoy these different settings, and then you get a better feeling what friction is doing and what stability is doing, for example, all right? So overall, I would say I will just go with the high mode for now. All right, and now I go to granular and let's see, I'm just curious. So let's put this one to the default value of 3. How will this look? Okay, so I make a cache and then we compare different frictions and after that we compare different stability values. Okay, so let me make a cache with a friction of 3. All right, guys, in the meantime, I did a couple more tests and rendered them out and put them all into After Effects so we can talk about it. So let's just quickly go through them, and I think about some of them we already talked in Cinema 4D. I just want you to feel really secure about the settings, what is changing what, and that's why I go through it one more time, all right? So this one is with a particle radius of 1, and you already know when you reduce the particle radius, then your grain will get tinier and therefore you will have more grain in the same object, and that means just a more detailed simulation, right? So this one and all of the other ones are with a particle radius of 1. Then I set my fluid FX to an accuracy of high. All right. This one has a friction of 3, stability 10, cohesion 10, and the caching time was 98 seconds. And I think you already know this one. The problem here is just that the friction is way too low, all right? So these particles, they just can't stick together and you won't get a realistic grain behavior. So this is almost like a typical particle simulation, right? So definitely you have to go higher with the friction, all right? And there you go. This almost feels like sand, but the next problem is that the stability or the cohesion is too low, all right? So you can see when I go up to a friction of 100, I mean, it changes it a little bit, but still this is quite loose when I go to the end of the simulation, all right? So the friction, that's what we increased, but I think we also have to increase the stability. And I was watching just one of the Ethereum training from Bob Wormsley, and he said these three parameters, the friction, the stability, and the cohesion, they are deeply interrelated, all right? So if you introduce more friction, then that also has an effect on the stability and the cohesion, but all of them are read as one package, so you have to change all of them to get the best result, all right? And when I understand it correctly, the stability and the cohesion control the clumpiness and how they are held together, all right? So these clumps, they are basically controlled by the stiffness and the cohesion. And the stability just basically tells them how much they will try to hold their original shape, all right? So if you put more stability into it, then you will get basically less clumps, all right? Because they just try to hold their original shape. And the cohesion, he basically explained like some springy constraints in between these clumps, which will hold them together. So you just think of them like there are little springs, and if you go to a high cohesion, then a clump like this and a clump like this, they still will be connected, and maybe it will come back and you will get some stretchy, wobbly behavior, all right? So just be careful if you go too high with your cohesion. I did it in this upper test here, but overall, I need to start another test series to really get behind these numbers. Also, Bob Wormsley from Ethereum said that the sensitive values in stability are between 4 and 20. All right, and when it comes to cohesion, it is between 10 and 30. So this is the area where you see the biggest changes. I went way beyond these numbers. Of course, you can do that and still see changes, but I guess the sensitive values are, as I said, when it comes to stability, between 4 and 20. And when it comes to cohesion, between 10 and 30. This is just the area where you see the biggest changes in the behavior, all right? But anyway, let's continue with our tests here. So let's activate the next one. And here we went up with the stability from 10 to 50. And now you can see this will stick more together and you get bigger clumps here. And I guess when we went even higher with the stability, then this should be even more coherent and stick together. The changes obviously are not that high. And as I said, the sensitive values are between 4 and 20 for the stability. So between 50 and 100, there is obviously not such big of a change, right? I mean, barely anything. And if you go up to 500, the change is also quite little. All right, so I went back to a stability of 10. I think this one is the same video like that. Yes, okay, I just placed it again here as a new starting point. So we start again with a stability of 10. And now I change the cohesion. But sadly, I didn't had this knowledge about the sensitive values that Bob Wormsley was mentioning. So they are between 10 and 30 when it comes to cohesion. But anyway, we should see a change here from cohesion 10 to 50. All right, and you can see it now. These clumps are bigger. Sadly, in this example, you can't feel this springy, constrained behavior that the cohesion is adding to the mix. It's not so obvious here, but as I mentioned, the cohesion is something that holds these clumps together with something like springs. You just imagine it like that. Also, this is what happens in the system. So there are constraints which hold them together like springs, but sadly you can't feel it so much in this example, all right? Then I went up to a cohesion of even 100, but the change is not so high, all right? All right, let me go to another example here, okay? So let's watch this one, or make this one smaller. So this time I decreased the particle radius to 0.8, and you can see the caching time went up to 297 seconds, all right, which will be like almost 5 minutes, okay? So if you compare it with the particle radius of 1, where we have simulation times around 150 seconds, so 2 minutes, then this decrease of the particle radius, you just pay it with additional minutes of calculation time, right? You can see now this is even more detailed, and I think that looks quite interesting. That looks cool. Let's go up to the next one. All right, let's just re-center this image here. Okay, and you can see this one is in comparison to the first one. I tried something with the viscosity. So I went from 30 to 300, and I guess this is a parameter you shouldn't change so much because the result here is a little bit strange, to say it at least. Okay, so it feels like this is ripped apart into really tiny pieces, like the inside pieces of a cushion maybe. Okay, so it has its use cases, but that's not what I want to aim for. Okay, I went back to the normal viscosity, which is 30. So all of the other examples, but this one has the viscosity of 30. I just wanted to test it here, what happens when I put it up. Okay, but I didn't like it. Next one, I changed the accuracy to accurate. All right, before I was always with high, and also all tests in the other composition here are all with the high setting of the FluidFX, but now I go up to accuracy accurate mode. All right, and you can see the time is also going up, but therefore you get some different behavior. So I think the higher you go with this pre-made modes, the more samples will be calculated, and therefore you also get a more sticky granular behavior. Okay, so if you put your FluidFX mode too fast, you almost get no granular behavior, and then when you go to medium, high, up to accurate, it gets more and more sticky and grainy. All right, so you can see the only thing I changed here was to set this one to accurate, but the behavior changed quite massively. All right, so in that case, I guess I need to go down with the stability again. You also can see a little Octane render here, how this will look with light. Okay, I really like the details here. I mean, this is still useful, but honestly, now I feel this one is sticking too much together and I have to reduce, for example, the stability. Okay, so when I go down with the stability now, you can see in this last example, everything is the same, but the stability is reduced to 30. Now we get these clumps again, and I think this looks more interesting. All right, so these are the magic numbers there, but as I said, you just have to play with it, and you start with a higher particle radius to test the friction, stability and cohesion. And to repeat it just once more, you definitely have to go up with the friction, so I think you start with 3, but then the particles, they just have no granular behavior, they don't stick together. That's why you have to go up with this particle to particle granular behavior and maybe set it to a friction of 100 or 70 or whatever you like. Then, when it comes to the clumpy behavior, to these clumps, this will be decided mostly by the stability and the cohesion. The stability tries to hold the original shape, so I think when you go up with this from 30 to 100, for example, or higher, then you will get bigger chunks. And when you reduce it to 30 or even go down to 10, for example, then you will get more small clumps, all right? And the cohesion is the parameter which tries to have this springy constraints between the pieces and will try to still hold it together. That's why when you go up too high with the cohesion, you will get maybe some springy behavior where this is going here and then back to the original object, and that could look a little bit ugly. So just be sensitive with these numbers here, and I think that looks quite interesting. Okay, cool. All right, just a little bonus. So maybe you want to control which particles are at which time affected. Okay, so for example, you don't want it to advect all from here, but you want to move like a fall off fluid and say everything in the fall off will be advected by the fire, for example. And therefore, we will just make a particle group and say when the particles will be in that group, they will be affected. Okay, so this is pretty simple. For you, just go to your granular, go to groups and make a new group. All right, let's call this one advected. Okay, and I think I just want to tint this one red. Okay, perfect. Now all of them are already in this red group. Maybe that's not exactly what we want, so let's go back to groups, create another group and call this one no advection. Let's go back to these groups and let's say group to use will be the no advection. All right, now they are in this basic group. Okay, and we want to dynamically change them to another group, and only these particles will be advected by the fire. We go to our exposure effects, go to advection, and now we can say which group will be advected. Then we just place the group advected in it, and that just means all particles in this group will be advected. All right, obviously now none of these particles will be advected. That's pretty sad. Okay, so let's just grab a change group modifier. Okay, and the new group should be this one. Okay, now I guess all of them will be in the new group. That's also not what we want. And I can also see these particles that create the fire, so the X particle smoke rising, is also affected by this one. So let's just exclude it here. Let's put it there. All right, that's better. And now we want to go to this one, go to the fall off and create, for example, a linear fall off. All right, just make this one tinier. And you can already see all of the particles which are right to this fall off are advected. So let's just see this one. Give it a little bit of time, but you can already see these ones are influenced. Alright, and obviously, because these particles stick together because of their sticky, granular behavior, the other parts will move with it. Alright, let me just be a bit more precise here. So now, with the linear field, we said all of these particles are in the group advected, and therefore they will only get the advection effect, okay? But for example, in that case, our friction is at 100, and therefore you will have friction through the whole granular object here, okay? And that's why when these ones are advected through the fire, okay, invisible again, they will carry the blue ones with them, okay? If you now go down with the friction, for example, to 10, I guess these ones will be advected and the friction is not high enough. This will be ripped off from the object, and this just depends on the friction value, how sticky these ones will be, and if they will carry everything with it or this will be ripped apart. Cool. And of course, nothing is holding you back from animating this linear field through your object to just give it an additional impulse that the advection will start here, and from 0 to, for example, 60, you move your linear field through it, and then the advection will be further controlled by this linear field, and you just have more control about the whole animation. Alright, and I think this is enough for today about advection and granular stuff. Thank you so much for listening. See you next time. Bye guys.